So far, you've seen how a reinforcement learning agent learns through interaction, choosing actions, experiencing the consequences, and refining its behavior over time. Now we'll put names to those underlying ideas. These core concepts will shape every algorithm you design and every experiment you run. Environment. The environment is the world the agent inhabits. For Lunar Lander, that world includes gravity pulling the rocket downward, the landing pad waiting below, the physics simulation that governs motion, inertia, etc., terrain shape, position, velocity, angle, and more. After each action, the environment produces the next situation and feedback. State. A state is a snapshot of the environment at a particular moment. It contains all the information the agent needs to decide what to do next. For Lunar Lander, a state might include rocket's horizontal and vertical positions, velocities in both axes, angle and angular velocity, leg contact indicators. The agent reads the state to understand exactly where it stands. Actions. An action is the choice the agent makes right now. In Lunar Lander, those choices are fire the main engine, fire the left thruster, fire the right thruster, do nothing. Each action directly influences the next state. Agent. The agent is the learner or decision maker. In our Lunar Lander example, it's the code that pilots the rocket. Its role is to observe what's happening around it, choose an action based on those observations, state, learn from the outcomes. Rewards. A reward is the numerical feedback the agent receives after taking an action. It tells the agent whether that move was good or bad. For example, landing safely earns a big bonus. Crashing costs a heavy penalty. Using fuel carries a small penalty. Over many episodes, the agent learns which actions maximize its cumulative reward. Policy. A policy is the agent's strategy for choosing actions. It maps each state to an action answering the question, given what I see right now, what should I do next? The goal of reinforcement learning is to discover the policy that yields the highest total reward over time. Why these ideas matter. When you connect agent, environment, state, action, reward, and policy, you get a complete picture of how learning unfolds through trial and feedback. Mastering these concepts lets you think like an RL engineer, frame problems formally, build agents that improve on their own through experience. In the next chapter, we'll weave these ideas into the Markov decision process framework. That framework will give us the mathematical language to model complex tasks and solve them with reinforcement learning. You've laid the groundwork for everything that follows. Get ready to explore MDPs and see how they bring structure to learning from experience.
To find the entire detailed lesson with all the instructions, math, and code, visit our website edreate.com. There you can find everything you see here and much more. Plus, you can find the full code on github.com/edreate. So don't wait around and sign up now at edreate.com.